Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civey, and today I'm going to discuss how you can control the volume of a fan box. In the podcast on ECM motors, I mentioned that you have to use a screwdriver to adjust the fan speed and therefore air volume of a fan box when you have a standard PSC motor and SCR controller. And I also mentioned how the ECM motor allows you to control the fan speed with your DDC controls. I'll go into more detail about that now. As a refresher, a standard PSC motor uses a SCR controller to control the fan speed. The SCR basically cuts the voltage to the motor, which slows it down and reduces your airflow. So let's draw a fan box in the ceiling here. A little ductwork on it and a control box. The SCR is located on the side of the fan box, and to adjust it, you have to get a ladder and a screwdriver. So let's draw a guy on a ladder here. And then put a screwdriver in his hand. Yes, that's a screwdriver. And now that he's up there, he has to turn a potentiometer on the SCR either up or down to increase or decrease the airflow. Some SCRs have little knobs instead of using screwdrivers, but you get the point. But most fan boxes these days have a direct digital controller, or DDC controller, on them. So it'd be much easier if the controls of the fan box could talk to the motor and tell it to speed up or slow down. In a fan box with an ECM motor, they can. This happens through the PWM controller. Fan boxes with ECM motors have a PWM instead of an SCR. The PWM serves the same purpose, and in fact you can get a manual PWM that allows you to adjust it with a screwdriver on the side of the box. The PWM gives you more information than an SCR though. You can get RPM of the motor and the duty cycle. The duty cycle is the percentage of a period that the PWM signal to the motor is active. Remember that PWM stands for pulse width modulated, and a PWM basically pulses a signal on and off over a period of time. So for instance, if over a 2-second period of time the PWM is on for 1 second and off for 1 second, the duty cycle is 50 or 50%. And so no signal is 0, and if it's on for 2 seconds, then it would be 100%. In the ECM podcast, I mentioned that the motor has a microprocessor that, when programmed, allows it to control the airflow regardless of changes in pressure. It's a pressure-independent motor. Because of this, we can tell you the CFM output of our fan box at any given duty cycle. In fact, we put a chart on the side of the box that looks something like this. So at 2%, it's 341 CFM, at 4%, 361, and so on. And then we'll just keep going here all the way to 100%. The duty cycle of 20 would correspond to a voltage signal in the PWM of 2.0 volts. So now I can take this duty cycle chart and plot it on a graph with voltage on the x-axis and CFM on the y-axis. And you'll see that it forms a line. Sometimes it's a straight line, sometimes it has a slight curve to it. Let's put voltage down here and CFM up here. The line can be described by an equation, say y equals 89.37 times x plus 360.35. This is actually the PWM calibration curve for our FLS low-profile fan box. Now the controls contractor can put this equation in his DDC controls, and using this equation plus what we call a remote PWM, he can send a voltage signal to the PWM to get the CFM output they want from the fan box. So say a 5.5 volt signal to the PWM would correspond to the duty cycle of 55%, and it would give, if you plug it into the equation up here, 851.8, or let's call it 852 CFM from the box. So the two most common ways we see fan boxes controlled through the DDC controls depends on what outputs the control actually has. If a controller can use two outputs and send both a 0 to 10 volt signal and a fan on-off signal, then they would do that and get the full range of the 0 to 100% duty cycle. If the controls can't send the separate fan on-off signal, then they would send a 2 to 10 volt signal to control the fan speed, which gives you a duty cycle between 20 and 100%. Then any voltage under 2 volts would be off for the motor. Now this opens you up to all sorts of control options. For instance, you can change the zone CFM based on different seasons or for night setback. So that's how you can control your CFM on a fan box with an ECM motor. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.